I gotta remember to record because I forgot yesterday. If you say 15 divided by 3 equals 5, we have names for them. The 15 is known as the dividend. Oh, 5. Thank you. Too early. Dividend. The 3 is called what? Divisor. And the answer is called the quotient. Again, when we get to the application problem, which is I think section 6, when you hear quotient, divide, dividend, that tells you have a division of the problem, because you're going to be seeing word problems. So it's nice to know the terminology there. They write them a little bit different than what I did. They play with the math there, but it's the same thing. The first one, when you're dividing, is called the dividend. The second one is the divisor, and the answer is called the quotient.
What's the date? Is it 15 or 16?
16. So how do we divide numbers? So let's take an example, and let's assume, take a number here. We collected some cans for a drive here. We collected cans for the Dana-Farber. They just had their fun drive. So let's say you're coaching a little leagues team there, baseball team, basketball team, and you decide you're going to do a drive there. You collected some cans. You collected 864 cans and bottles there. And now you want to take them to the recycled center. But before you get to the recycled center, you stopped at a liquor store. Well, let's not use liquor, the little kids here. At the soda stores, and you got boxes. They give you a lot of boxes. Each one is going to hold 24 cans in them. One, two, three, four, five, six. So each box can hold 24 cans in them. So how many of these boxes do we need? So we're going to take these cans, put them in cases of 24, put them in a truck, and take them to the recycle center so we can cash them in and get some money. So we take 864 divided by 24 cans. Or each box holds 24. Can you divide the 8 by 24? No. How about the 86 by 24? Maybe 3. 3 times 24 is what? I think it's 72. Notice we subtract the 2 from 6, which is 4, 7 from 8, which is 1, and bring this one down. Now 144. I think it might be a 6 there. What's 6 times 4? 24. 4 carry 2. What is 6 times 2? 12 and 2, 14. What's your remainder? 0. So how many cases you have? We have 36 boxes to carry now to the recycle center. I'll give you another example. It's not always going to be the remainder of 0. Sometimes you have a remainder. So that's one example here. Let's try another example. Let's say poor grandma, she passed away. And grandma has, when we looked at her checking account, we found out she has, in her checking account, she has $20,856. With a little note, please divide this money equally between my 4 kids. She has 4, grandma has 4 kids. So we're going to take this money and divide it by 4. How much does each one of them get? So we take 20, 856, divide that by 4. 20 divided by 4 is what? 5. 5 times 4 is 20. No remainder. Bring the 8 down. 8 by 4. 2. 2 times 4 is what? 8. No remainder. Like a 0 here. Bring that 5 down. 5 divided by 4. 1. 1 times 4 is 4. Remainder is what? 1. And now bring that 6 down. 16 by 4, which is 4. 4 times 4 is 16. So each one of us, or one of her kids, will get $5,214. Sometimes you have to divide big numbers. Like what? I saw yesterday a sign, I'm driving, and I don't know if anyone won or not, so I gotta go buy some tickets. I think the Mega Million or the Powerball is worth what, 220 million? That's what the sign, 220 million. So let's say we decide to go as a class there. How many of us here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 with me. Let's see. So the government's going to take some money out of the 220 million. So let's see. We said how many? 14 of us. So the Mega Million. Here we go. Mega Millions, I think. It says $220 million. The jackpot. But if you take the one-time payment, they're saying if you decide to go one payment, you're not going to get the 220 million. Let's say they're going to give us 118 million, usually much less than that. $659, 772. So you lose almost about 100 million, close to that number. So we bought tickets. There's 14 of us. We said, hey, let's just each one throw $4 or $5, and if we win, we'll divide the money equally between us. Now, what do you know? I got a call from you guys screaming. I can hear you screaming, we won, we won. So how much does each one of us get? Let's divide that. 118,659,772. We're going to divide that by 14 people. Can you divide 1 by 14? 11 by 14. 118, yes, I think might be an 8. 80, yeah, maybe 8. What's 8 times 4? 32? 32. What's 8 times 1? 8, and 3 is what? 11. So the remainder is what? 6? There's the comma. So you know you're getting more than 8 million already. Now you bring that number down. So what is that number? 4? Okay. So now let's do the multiplication again. I erased that one. What's 4 times 4? 16. 6 carry 1. What's 4 times 1? 4 and 1, 5. What's the remainder now? 10. Bring that 5 down. 105. Might be a 7, I think. 7 times 4, 28. 7 times 1, 7. And 2, 9. What's the remainder? 8 from 15, 7. Bring the 9 down, right? So you got to bring that 9 down now. 79. Maybe a 5? 50, 70. Yep. 5. 5 times 4, 20. 0 times 2, 5 times 1 is 5, and 2, 7. Bring the 9 down. Here's the comma now. Let's bring that 7 down. 97 divided by 14. Well, 98 was what, a 7? So that's less than 7, that's a 6. 6 times 4 is 24. 4 carry 2. 6 times 1 is 6, and 2 is 8. The remainder, 4 from 17, which is what? 4 from 7, not 17. 3. 8 from 9. 1. Bring that 7 down. It's a big number here. That's like a 9 here. 9 times 4 is 36. 9 times 1 is 9 and 3. 12. 6 from 7 is 1. 2 from 3 is 1. And bring the 2 down. Maybe that's an 8. 8 times 4, 32. 3. 8 times 1 is 8 and 3. 11. What's your remainder? 0. So when you divide that number, the 118 million that we won, 6, 5, 9, 7, 7, 2 divided by 14, each one of us gonna get 8,475,698. And Jakeem, you get nothing because you showed up late. We already collected the money and we bought the ticket.
Sorry,
We'll get you a pizza.
I get lunch.
So that's it. So each one of us will get 8,475,698.
You can't give me one?
Nope, you came in late.
Damn.
Nah, you didn't win. You know?
I could have been rich.
Okay. So that's when you see the big numbers. You're talking about Powerball, Mega Million, stuff like this. We can divide. And again, sometimes you do have a remainder. The numbers just don't work out nicely. So when you have a remainder, you just go R something. So for example, you had a scratch ticket. Scratch tickets for, I don't know, it says, guess what? You won $100. And you decide you're going to divide between the three of us walked in together. We bought a scratch ticket. Each one threw $1 and we won. So divide that by 3. So what's 100 divided by 3? Can you divide the 1 by 3? No, the 10 by 3.
Yes. Wait.
3 times 3, 9. A 10 by 3. 3 times 3, remainder is 1. So we can get 33, each one $33, and at the end we have a remainder of $1. We can buy a candy bar with it and share it.
At least I get the higher.
We'll give Shaquem the candy bar since he missed on the 8 million. You know, that's what he gets.
This is one candy.
Yep,
That's $8 million.
yep, that's all you get. So don't be surprised to see some remainders again. 5, 2, 9, 3, and I want to divide that by 32.
Is there a remainder, like what's left over?
Correct. As long as less than that number, like in this case, less than 32. So let's try the 1. 1 times 32 is 32. Bring that 9 down. 209 by 32. I know 30 times 6 is 180. So it's probably about a 6. 6 times 2 is 12. 6 times 3 is 18, 119. 2 from 9. 7. 9 from 0, you can't. 9 from 10, that's a 1. Now you bring that 3 down. 173. That's under 180, so maybe it's a 5. I go 5 times 30 is 180. 5 times 30 is 150. So 6 times 30 is 180. So maybe between 180 and 150. That's what that number. So 5 times 2, 10. 0 carry 1. 5 times 3, 15, 116. So when you divide 5293. You divide it by 32. Your answer is going to be 165, and you have a remainder of 13. Again, if these are like bottles of water, when you go to Costco, you buy these 32 bottles of water case wrapped in plastic. Like if you have that many cans or that many bottles, you want to wrap them in plastic of 32. You'll have 165 of these cases, and the last one is going to have only 13 spots filled out of the 32. You have a remainder of 13. So again, don't expect the numbers always to be perfect, so you could have a remainder. Now what about estimation? The book talks about estimation. I'll put that on your screen. And again, the reason for estimation is to make the math really easy for us. Where is the estimation? Let's see if we can get estimation here. Here we go, estimating. When it says estimate or round, when you hear that any problem, multiplication, division, addition, subtraction, doesn't matter what, you're supposed to round the numbers first, then do the math. So round first, then do the math. The mistake most people do is they want to actually do the math. So notice if you have this one, if it says estimate, $7,004, and I want to divide that by 34. So I might decide to round the numbers to nearest 10, just to make the math easy. Here's the number. Nearest 10, this is the 10 location. Remember the rule of rounding. You look at the digit to the right. Is that digit 5 or more?
Nope.
Nope, so that becomes 7,000. This number, that's the nearest 10. Is that digit 5 or more? This becomes what? 30. And now you're going to divide them. It makes the math a little bit easier. So we go 7,000
That's 500.
So you want to, okay.
divided by 30. Can you divide 7 by 30? No, how about 70?
Yeah.
2.
No. Yeah, you know.
2 times 30, 60. What's the remainder? 10. Bring that 0 down. What's 100 divided by 30?
I do not know.
3. 3 times 30 is what? That's 90. 10. That's about a 3. And what do? You got about 90, and there's a remainder of 10. But you're looking for estimation. That's what you're looking for. So you might say, well, this is going to be about nearest 10. This will be about 230. So we're trying to get an estimate, a neighborhood answer. The truth is, actually, if I was doing this, I'll go 200. Why? Because I'm just getting a rough estimate. I'm not looking for the exact answer. I go, well, 30 times 20 or 30 times 200 is what? What's 30 times 200? There's 3 zeros. What's 3 times 2? 6. That's close enough. That's how we do estimation. We're not looking for the exact answer. So if you want to do the math, you might say about 230. Again, you're going to be off there, but we're looking for an estimate, a neighborhood answer.
Okay, so 100.
So always round the numbers. Try to do the math in your head, basically. Now, if I want to do this math, why am I not just dividing the real numbers? So that's why people don't want to do this. They just want to go, oh, approximately 200. So you're trying to find a neighborhood answer. You might be off by 1,000, still, oh, that's close enough. Again, if I have another problem, here's one, actually, there's one for us. Estimate. You have $10, and you go to buy milk. The milk is what? $2.94 a gallon. How many gallons you gonna buy? Estimate.
3.
3. There you go. I can buy 3 gallons. $3 roughly. That's about 3 gallons. That's all you can buy. And if you did the math, it's gonna be what? 3.4, 3.5. What is Stop and Shop gonna let you open a gallon of milk, dump some of the milk out? You can say, well, I can only get 3.4. No, you can only buy 3. So estimation, again, you're not looking to do the math, you're looking to get a neighborhood answer. Just like with multiplication, the same thing. If you're looking at a Christmas tree, not shop here, we're talking about a farm here, and you see all these Christmas trees, you go, well, how many trees in a row there? Well, each row has 52 trees. How many rows they got there? 33 rows. You go, oh, that's roughly what? 50 times 30. Because you got to do a quick math. What's 50 times 30? What's 3 times 5? 15 and 2 more zeros. There's 1,500 trees they got there. It is a neighborhood answer. And the same thing with dividing numbers. If somebody said to you, estimate, $25. Jakeem, she's gonna kill you if you keep popping that gum.
Sorry.
Okay. She looked at you twice already. Okay. So if you take this multiplied by 100, just think about it. What's 25 times 100? Isn't that 2,500? Right? If you multiply by 100, is that close enough to that answer? Probably. They might say 100 trees. 100 answer. So you're looking for just a neighborhood answer. You might be off by 1,000, 2,000, 3,000. When you're dealing with 25, 23,000, what's 1,000 or 2? So the answer to this is estimation is 100. Normally they'll say round first, then do the estimation for the homework because they're not sure if you think that's close enough or not. So they might tell you to round that to nearest 100, and this is to nearest 10. Then estimate the math. You know. Let's see. That's this section. The one thing to remember about division, I know our book doesn't talk about them, but I'll mention them because you'll see them a lot down the road. And that's when you're having zeros. And by the way, what is a number divided by itself?
A prime number. Did I say right?
No.
Oh.
What's a number divided by itself?
I don't know.
What's 5 divided by 5? 1. What's 8 divided by 8? 1. What's 9 divided by 9? 1. Any number divided by itself is always a 1, except the 0. 0 is a different story.
Oh, okay. Well, I still thought it was a prime number.
What is 0 divided by a number?
0.
0. So 0 divided by 5 is 0. 0 divided by 8 is 0. 0 divided by 10 is 0, except 0 over 0. What is 4 divided by 0? What is 9 divided by 0? What's 20 divided by 0? Try again. I heard somebody from that side said it right.
You said 20 divided by 0?
Yep. No solution, can't be done. Can't divide by 0. You can't divide by 0. It's an error. Notice, I'll show you my calculator here. This is a cheap calculator, like for $7-8, so it's not an expensive one. And if I said 8 divided by 0 and I hit enter, it should give me an error.
Is it because the bigger numbers on top?
Nope, can't divide by 0. So I always have this saying,
Okay.
0 on the bottom is a problem. That's why I say. Is a problem. 0 on the bottom is a problem. One day I'll make a song about this. I just gotta find somebody to sing it with me. Who? Yes. Then I can make a rap song. Zero on the bottom is a problem. Yo, baby, yo, baby, yo. There we go. Or me and Iggy Azaleas will sing it together. I'm thinking of changing my name to Ziggy, Z-I-G-G-Y, you know?
This is live.
It's on tape too. Zero on the bottom is a problem. So that's why when you divide 0 by 0, it's not really a 1. Notice any number by itself, it's a 1. But 0 by 0, no solution. We said when you have 0 on the top, it's always a 0, except 0 over 0, no solution. Once you see 0 on the bottom, I don't care what the top is, the problem has no solution. It is a problem. Notice if I go 0, where's the 0 here? Divided by 0 equals error. You can't divide by 0. So remember that 0 in the bottom is a problem. So if you see any of these problems, you can't do them.